Hi, and welcome to Math Girl. It's me, Math Girl, and today our lesson will be on simplifying radicals. Wait, now take it easy. Don't get nervous now. You've been dealing with radicals your whole life. You know, things like the square root of 4, and everyone knows that the square root of 4 is 2, or the square root of 9, and that becomes 3, and when the square root of 8 comes, I know what you all do. You all get up and go and run and grab your calculator. Well, when it's time to simplify a radical, it doesn't mean to rock a calculator and start typing buttons in and screaming out some random decimal. What it does mean is to find another expression that has the exact same value. So when you're asked to find the square root of 8, instead of jumping up and typing buttons, why don't we try to simplify this radical a little nicer? So when you have the square root of 8, the first thing you should do is try to identify the factor pairs. What are the different kinds of numbers that multiply to 8? So I know that 1 times 8 makes the number 8, but neither of those is a perfect square, so it's not going to be helpful. We could do 2 times 4, and well, we're going to stop here for two very good reasons. First of all, I don't have any other factors of 8. And secondly, I noticed that in my factor pairs for 8, I have a number that happens to be a perfect square. So we'll use this cool trick called the product property of radicals. Now, mathematicians, we're not that creative. We call it what it is. It's called the product property of radicals because you can use the square root of 8 and write it as two different radicals. As long as these two numbers here make 8 when you multiply. So I'll write the square root of 4 multiplied by the square root of 2. It's still the square root of 8, but now I can take this number and eliminate it, and I'll write that as 2 times radical 2, or just 2 radical 2. And this is how we simplify the square root of 8. Now let's try that one more time. What's the square root of 200? I know, it's some random number again, but let's try our trick. Let's try finding the different factor pairs of 200. 1 times 200 is totally helpless to me. It's like a little ant you want to step on. Or we can do 2 times 100. And now you can keep going if you want to. 3 times what and 4 times what. But I noticed that 2 times 100 will work just nicely since 100 is a perfect square. So what are we going to do with the square root of 200? Rewrite that bad boy. It'll be the square root of 100 times the square root of 2. Did you remember what that's called? Did you forget? Oh, Yvette, you can't forget. You have to remember. It's called the product property of radicals. Why? Because you're multiplying radicals. So product radicals. Get it? Man, you guys are silly. All right, so the square root of 100 cleans up nicely. That becomes the number 10. And then, of course, we still have times radical 2. So our final answer is going to be 10 radical 2. Now, please don't show all these steps. After a while, these become very, very repetitive. So when you start seeing things and you start seeing the same numbers over and over again, you don't have to show every single step. So what two numbers multiply to 75, but one of them has to be a perfect square? Go ahead, I'll wait. I don't mind. I'll get some coffee while you're thinking. No, I'm just kidding. Did you figure it out yet? Of course you did. It's going to be 25 times 3. Now, why did you pick 25? Well, because 25 becomes 5, and our final answer would be 5 radical 3. Yes, this is the simplified version. You don't have to go any further than this. So, what if we try one that I'm going to purposely mess up? I'm going to look for two numbers that multiply to 32, one of which is a perfect square, but I'm going to do it just a little bit differently this time. I'm going to write this as 4 times 8. And I did that so that the square root of 4 becomes 2, and we still have a radical 8. Now, a lot of you are going to stop here, high five yourself, think you're amazing, but I want you to think about the number 8. Did we not do this example a couple of seconds ago? This becomes 2 radical 4 radical 2. You see, 8 can still be simplified. You're not done with this 8, okay? When you do that, this square root of 4 becomes a number 2, but there's already a number 2 hanging out here. What do? Do I make it a 22? It seems like a lot of 2's in here. Remember that at the end of the day, you are multiplying. So this is still 2 times the square root of 2, and 2 2's and 7 2's and a lot of 2's. Well, what if we had done it right the first time? I'm going to change color for a second. What if I had picked the right factors? What if instead I had written this as 16 times 2? This is the square root of 16 times the square root of 2, which is 4 radical 2. So we have two plans here. If you happen to pick the right factor pairs the first time, you'll do it in a couple of steps. But if you happen to pick the wrong factor pairs, you'll still end up with the same answer. It will just take you a little bit longer. So, what if there's already a number outside the radical? I think we addressed that, but I'm going to say it again because you're probably not listening. You're watching Glee or something like that. I'll have a -3, and I'm going to change out the 20. I know you know what that is. That's going to be 4 times 5. You're going to see that 4 a whole bunch of times. So this is like saying -3 times the square root of 4 multiplied by the square root of 5. Now this still says -3 times the square root of 20, but we're dealing with a lot nicer numbers here. So this becomes 2. -3 times 2 times the square root of 5. Our final answer would be -6 radical 5. And this is a great time to celebrate. So now you can go out and watch Glee. No, just kidding. Let's keep going. What if there's a fraction? Okay, well, guess what? Fractions are our friends, okay? You're not supposed to be scared of a fraction. What's it going to do? Bite you? This is like saying 1/2 times the square root of 8 times the square root of 4. Oh my gosh, did you see what I did here? I picked 8 and 4. What is wrong with me? Let's try this again, but this time I'll use a better color like blue. That's not Mets colors. 32 is going to be 16 times 2. So this entire question gets rewritten as 1/2 times the square root of 16 times the square root of 2. The square root of 16 is like saying the number 4, so this is 1/2 times 4 times the square root of 2. Our final answer is going to be 2 radical 2. And we have seen this all the time. Now let me tell you something. You're going to see that a lot, so you want to start memorizing that. And I always get the same next question. What about if there's a variable? Oh my gosh, there's a variable. What are we going to do? Freak out? Don't freak out, okay? Variables are fine. Think about x squared. If you're finding the square root of x squared, you try to say what number multiplied by itself magically gives me x squared. Well, guess what? It's x. So if you want to know the square root of x squared, the square root of x squared is x. And as a matter of fact, that's going to work anytime you have an even variable, like an even exponent. Like if I had x to the 4th times x to the 4th, that's x to the 8th. So if I asked you for the square root of x to the 8th, you're just going to write x to the 4th. It works itself out. Let's try a different one. What if I throw an 8 into the mix, right? Don't get scared. It's going to be the square root of 8 multiplied by the square root of x squared. And we've seen that 8 so much, you know you could take it to the square root of 4 times the square root of 2 times the square root of x squared. And this is all by that cool product property trick. 2 square root of 2 and x. Our final answer is going to be 2x radical 2. So this is a cause to celebrate. No more Glee. This time we'll watch some Survivor. All right, what if it's odd? Well, I always tell my students that an odd exponent, you do the same thing. I'm going to break it down to two numbers. Kind of like when I do a 45, I break it down to 9 times 5, and I pick the number 9 because it's 3. It's like saying 3 radical 5. I'll do the same thing up here. I'm going to try to find two numbers that still give me x cubed. That's x squared times x, but this x squared pops right out of my radical, so it'll be x radical x. Man, all that blue on the screen makes me want to go back and see a Mets game. X to the 3rd power, x squared times x. Why did we pick x squared? It's a perfect square. It pops right out of my radical sign. X radical x. This last one, I promise. I know you guys are scared now. 27x to the 5th. Let's rewrite this completely. I'm going to write this as 9 times 3. I'm going to write this as x to the 4th times x. You see what I wrote here? This still says x to the 5th, and this still says 27, but the 9 comes out of the radical. It gets to come out of jail. That x to the 4th gets to come out of jail, visit its homies. But you know, when you come out of jail, that radical sounds like a jail. When you come out of jail, you're a changed man. So that 9 does not come out as a 9. That 9 pops out as a 3. This x to the 4th doesn't come out as an x to the 4th. It comes out as an x squared. But who has to hang out in jail? That's right. That 3 and that x still have to hang out under the radical sign, because you know only when you're perfect do you get to come out of the radical sign. Speaking of perfect, that's done with me. Thank you guys, and hope you enjoyed our simplifying radicals.